Welcome to round 3 of the physical simulation. In this series we are looking at how to design the system to achieve the 7 functional requirements of system design, and we will determine if by achieving those 7 functional requirements we're able to meet the customer requirement of 8 red, 8 green, and 8 blue Legos. This graphic illustrates the major differences in round 3 that we are practicing. First of all is the mindset of the people in our simulation who will be asking themselves the question, are we achieving the 7 FRs? Part of the design process is to decide which components or which part types are in the part family and to calculate the takt time, which is the time to produce one piece based on customer demand. So it's the average pace of customer demand is the takt time. And then we will balance operations to takt time. So we will see if an operation cycle time, which is the time per unit, is less than or equal to the takt time, which again is the average pace of customer demand. And then we'll look at how to implement a pull system to provide the communication between operations about what product to produce and when to produce it. We'll look at the importance of implementing standard work, which we're calling white sheet standard work, which is the fundamental or foundational standard work process to define normal in our simulation. And then we're adding Kanban cards to the containers for the pull system. In take 1, Shahab and Sarah again are operating assembly, and then we'll look at why in take 2 that Shahab was moved to supply. This figure is the Toyota house model, which you have seen in other readings in the course, but as a reminder, the Toyota house model is based on the needs of the customer to deliver products on time and to deliver high quality products. Toyota said that the purpose of the system is to make only what is needed when it is needed in the quantity needed. And this is captured by, and as we'll see on the next slide, the functional requirements of producing the customer consumed quantity, and the next requirement, functional requirement, of producing the required customer mix. Likewise, the quality pillar of the Toyota house is the Jidoka pillar, and it is based on achieving the purpose of do not advance a defect. This is implemented through in cellular manufacturing through the means of automation, which is the separation of the worker from the machine, which is a key part of volume flexibility. Jidoka and the automation principle means that we automate with the human touch in mind. The foundational pillars of JIT and Jidoka are level production and standard work, which balances the work of each individual and each operation to the takt time. And of course, the brick wall in level production is being able to change over rapidly. We'll see how significant that becomes in assembly. Shingo called it the goal single-minute exchange of dies, although Toyota today is now under 3 minutes in their stamping processes for changeover time. So when someone asks you, how do we design a system to become lean, tell them the 7 FRs. And then we need to get collective agreement about the functional requirements of the system if people do disagree with the 7 FRs. So that's part of our challenge, is to gain agreement about what we would like to achieve first before we start talking about tools and technologies to implement that are quote unquote lean or industry 4.0 or agile. And so the 7 FRs are to continually improve, to provide a safe and healthy work environment, and FRs 2 and 3 are aligned with the JIT pillar of the Toyota house model to produce the customer consumed quantity every shift and to produce the customer consumed mix every shift. And notice that that's not the forecast consumption, that's the actual consumption of the customer. And then FR4 is do not advance a defect to the customer of your work. And better yet, it would be to not make a defect at all, but FR4 is capturing this Jidoka pillar of the Toyota house model. And then next, as we saw with Subaru, the idea is to immediately identify abnormal conditions. So we have to define normal through standard work. And then if we have an abnormal condition, we'd like to have a way of resolving it for the long term. And we'd like to also have a process whereby the resolution is predefined in the form of what we're calling green sheet standard work. Green sheet standard work identifies the sequence that operations uses to, first of all, identify the abnormal condition and then to put in place a solution to bring that abnormal condition back to normal. And then finally, FR6 is the robustness FR, which is saying that we'd like to achieve all these previous FRs in spite of variation. So we've attempted to drive out variation, but we're also flipping the coin and saying that if we do have variation, we want our system to succeed. So the challenge of the simulation is, what are the PSs that we need to implement in the simulation to achieve the 7 FRs? In round 3, take 1, we're focused on connecting each of the operations in the system together via a pull system. The reason for this is to establish that communication about the demand from the downstream operation in terms of the upstream operation being able to produce the quantity required and the mix required by the downstream operation.
Hey guys, now today we are going to go for round 3 of the simulation. So Joe is going to talk about what are changes that we have implemented between round 2 and now round 3.
Great. So instead of a push system, as we had in rounds 1 and 2, we've implemented a pull system to tack time. And so we have our Hijinka box at the end, and we're going to let information flow backwards through the system instead of pushing it through the system.
Correct.
And we're relatively new to pull system, I would say. So we've all worked on our standard worksheets to understand what our role is in the system. These are just rough ideas right now, and we're going to use this as a trial to refine that. So everyone's going to introduce their roles now and what they think their job is within a pull system, and we're going to use this trial run to also understand balancing, where we need operators and how we're going to achieve tack time in every role.
Trying to design the system to take time.
Correct.
All right.
So hi everyone. So this time we are not forecasting raw materials. So simply we're gonna recalculate what is consumed by the assembly. So we have the Kanban card in it. It says 6 large rate. So what I'm gonna do is that I'm gonna put that in my tray and wait for 30 seconds. And meanwhile, I will be refilling these 6 large rates. And once the timer rings, I will simply ship back to the customer, which is my assembly, and I will get all the empty containers, or which is the consumed by the assembler, and I will repeat the same time. This time we have standard work, so it will be easy. And at the end of the simulation, my goal is to maintain the 4 sweeps what we have right now.
Hello guys, so as Taikyono says, where there is no standard, there can be no Kaizen or continuous improvement. That's why we are starting off with the standard work. Initial standard work is what I would like to call it. According to this, the inspector is going to pull a finished product from our first in first out assembly area based on the Hijinka box recommendation. And then what are we going to do, sir?
I will be replenishing what is consumed. So I'll be pulling one large red and two small reds, and then finishing with a large red.
Awesome. Yep, and if they have the yellow part, a defective incoming material, what do we do with that?
I will be separating them out and putting them in the yellow bin.
Awesome. So the main difference that we are going to have this time is we are not going to just keep on producing and pushing to the downstream customer. We are only going to produce what is consumed. That's it.
I'm the inspector, but my role has evolved a little bit. I'm now going to manage the Hijunka box. And so our tack time is 8 seconds for our calculation based on 8 parts of each color and 3 minutes and 12-second simulation time. So we are going to ship in container sizes of 8. So there's a red card for 8 red, 8 green, and 8 blue. And so this is our pitch here, is when we're going to pull. That's our container size, so 8 times our tack time, which is 8, so 64 seconds. So on the top of this Hijunka box, you can see 64, 128, and 192. So at the start of the simulation, I'm going to pull my first Kanban card. It tells me that I need to produce 8 parts, or I need to ship 8 parts. So I'm going to put that here, and I'm going to begin pulling parts from assembly. And when I get to my 8, assuming some of these might be defects, since I'm also doing inspection, when I get to my 8, I'm going to take my Kanban card and place it on top of my shipment, and I'm going to place it here ready for shipping. And I'll have 2 timers. One will be the overall simulation time, and the other one will be every 64 seconds. So after 64 seconds goes by, as I'm doing the red parts, I will then pull the green. I will place that here, and then I will begin pulling green parts. And that's my role up until hopefully we produce 8 of each color for the customer. Three, 2, 1.
Sir, why are you not producing the reds?
Don't just stand around, please.
He needs red parts.
I don't have any red parts.
Why don't you put blue?
I don't need to replenish what's consumed yet.
Oh, I see. Now I understand.
Oh, I need this.
Ask me again. I'll tell you the same.
Why are you not producing any green?
I know.
Hands up.
Yeah.
Very bad, very bad.
I said that. You work hard. So, to recap this round 3 simulation, let's ask the customer or the shipper, what do you think, is the customer going to be happy with the output of the simulation?
Not entirely.
Oh, why is that?
Customer got 8 green and 8 red, but only 6 blue. I noticed the entire simulation pretty much, we were behind tack time. So, we were behind on when I was supposed to pull the next Kanban card, I did, but I also hadn't finished the red ones when I pulled the green.
Right.
And that made my work really weird because I was
Why is
trying to handle inspection of red and green to try to make up for the fact that I didn't have red when I needed it to be able to meet that shipment.
So why couldn't you finish red on time as per pitch?
Well, these SWIP locations here in red were empty when I needed to come back and build my shipment of 8 red. And we didn't have much fallout. We only had 1 red and 1 blue that was defective.
And still we couldn't meet.
So I also had that issue in green, and when I came back on my last one to finish blue, I also did not have the blue I needed
Just
to.
like right now, there's no blue.
Blue ended with no SWIP, so
Right.
what do you think may have caused that?
Well, I guess both of us, the assemblers, were idle for pretty much one fourth of the time during the simulation because we did not get the material on hand on time. So let me ask the supplier, why couldn't we have the material on time?
I would say at the beginning of the simulation, I was idle for 30 seconds, and when I started accomplishing the containers, initially I had very few to fill, but as we did it again, as I was shipping, there were a lot of things and my work wasn't balanced with the tag time. So I had so many things to do. I had to refill it, ship it. So yeah, I was having hard time with that. So if I get any kind of help so that someone is assembling or someone is refilling the containers, so that would be good.
So if you had somebody maintaining your SWIP for you, so you could simply figure out what was consumed in
Mhm.
Just the
assembly
trucker roll and
and get the truck ready for the next shipment?
Yeah.
Well, I propose I can move to the supply end and help him with the supply. As we can all see, supply is delaying the whole simulation. Whereas Sarah, do you think it would be okay with you if you handle all the 3 part families?
Yeah, I think I can manage assembly, as long as my work is not being interrupted by the incoming or outgoing materials. So if that's something you can handle, then I can get my work done.
Awesome, let's try it then.
Sounds great. So I think we'll go back and write up new standard work.
Yeah.
Improved standard work on what we've learned in this round, and we can implement that and
Sure.
try it out and see how it goes.
PDCA improvement.
Thank you.
Mhm.
So now that we've studied the assembly cycle time, we know that assembly can meet the takt time. Standard work, remember, it defines the content, sequence, and timing of all work. So that means that we have to have 4 standard works for each of the 4 people in our simulation. So we'll need a standard work for Shahab, who is doing supply now, material replenishment with OnCar, assembly for Sarah, and functional test and shipping for Joe. The next few slides indicate the standard work for each of our people in the simulation and whether or not their standard work meets tack time. We see here a value stream map where the Heijunka box is simulating the average pace of customer demand and pulling parts into shipping from assembly. The pull system establishes the connections between shipping, functional test, assembly, and the supplier. For take 2 of round 3, Shahab will be the supplier, Ankar will be handling replenishment, Sarah will be doing the assembly function for all product types, red, green, and blue. Joe will be managing functional tests and shipping. We've also changed the layout based on improvements and thinking about the required tack time. So Joe and Sarah's standard work will be based on the 8-second tack time, whereas Ankar and Shahab, their standard work will be based on the replenishment time of 30 seconds, which we established as a design parameter for the simulation. Notice the improvement in layout and also the 5S organization.
So right now, this is the take 2 of this round 3 simulation. What are changes made on the shipping end?
Mine's pretty much the same. I'm going to pull at pitch, which is every 64 seconds. I'm going to do all the reds, all the greens, and all the blues. I'm going to pull from these nice SWIP areas here, red, green, blue. And so that's my role.
Any changes to how assembly is going to perform?
All of the material now has been streamlined in front of me, so they're in these nice rows where I can just pull my product from, assemble my parts, and then put them into the SWIP spots, and then my defects are over here, so it's just a lot more organized.
Also looks like the parts are organized better in
Yeah.
the containers.
Now the supplier has a helper, so that's what one of the things that I'm doing is organizing the parts in the container so they're not jumbled, easy to assemble. Another thing is Ankar is going to be a trucker, just delivering the parts, getting me the empty containers that I'll be using those Kanban cards. I'll be finishing here and we'll be getting the full containers from here, right?
Yeah, so I will be the shipping one, and I will put the empty containers there. Shah will refill it. Yeah.
Yep. So that's it. Let's see
Yeah,
how it
and-
goes.
We also have the updated standard work.
Yeah. All right, let's give it a try.
Everyone ready? 3, 2, 1.
Don't know that.
That's it.
Now you refill. That's it.
Alright, so take 2 of round 3 simulation. Joe, is the customer happy with the output?
Pretty much the same as the previous run. I have 7 red, 8 red, 8 green, but I only have 7 blue. We only had 1 defect, which was good. We didn't overproduce on red or green, despite the fact that we didn't have defects, so that was good. I still had the same trouble this time. SWIP was empty a lot of the times that I needed to pull from it. So I'm not sure what the issue is downstream, but did you have trouble getting material, or?
Yeah, when I was doing red, I would use all of them and then I'd be standing here waiting. And I'd have to wait for that to be replenished.
Yeah, I think this time my work was very balanced. I had very few things to do and I'm really happy with that. But the problem is that I have 30 seconds of constraint and the Sarah is demanding 1 color at a time. So in the beginning she was only consuming the red, and at the middle of the simulation she was only consuming the green. Now you can see she was only working on the red one, so that it was giving me hard time to fill the container as soon as possible. There was a little bit of delay, but yeah.
I don't see why, when I finish my red, why I can't move on to my green or my blue, because I know at the end of the day I have to have 8 of all colors. So I don't know why I have to wait to replenish the red.
But you're only replenishing what is consumed, right?
Correct, and at the beginning you're only consuming the red parts. And for I'm waiting.
So you have material available to you to produce red or green and blue.
Correct, just
while
sitting
you're
there.
waiting on the red.
Yep.
But you don't, because you just simply replace what's consumed.
Correct.
So let's see what the audience is going to suggest to us now.